Hey folks, it's Andrew from Beurer, and today we're going to take a quick look at the Beurer infrared heat lamp. And it's a very simple design. It's very well thought out that you have handles here to move it around. It's a little bit adjustable, and then you just press this button to turn it on. It starts right away with a 15-minute timer, and you can see it's actually a halogen bulb behind the glass there, and you can see how dark that glass was before, so it's cutting off a lot of the visible light spectrum like the blue light and the green light and actually most of the red light. So it's really not that bright because it's so dark, it's blocking a lot of the red too, but that really just lets make sure it's mostly the infrared that's coming through. So anyway, I've had this on my desk for a couple of months. I turn it on every once in a while and warm up my face, and it feels great during the winter. I think positioning it can be challenging because it is a heat lamp. You can't touch it. You actually need to be between 12 to 16 inches away so you don't overheat your skin, similar to like any incandescent heat lamp. So it's harder to position. Like if I have soreness or pains in my lower back, in my wrists, in my elbows or knees, then you kind of have to find a table that's perfectly the right height and kind of scoot your way up to it and kind of line yourself up with it. So it's kind of inconvenient because it's not really made for anything else other than kind of sitting on a table and kind of aiming it at you, and then you have to position yourself to try to aim it where you want to target. But otherwise it feels really nice. It feels very gentle. It doesn't feel as harsh as a lot of the 250 watt chicken coop lamps feel. It's got this nice kind of diffuser over the front, and like I said, it's blocking even a lot of the visible light, so it's not too harsh on the eyes, although that could kind of deceive you because you don't get that brightness aversion response, and you don't want too much infrared in the eyes, and you have to be careful about that. So sometimes they include goggles with these units. Mine did not, so there's some debate if you should wear goggles or not. I've got a lot of content about this. As long as you're far enough distance away with your eyes and with your face, you're getting a low enough intensity, then it's generally beneficial for the eyes, even with the infrared. But everyone should learn the science and take whatever precautions that they think they need, or check with their doctors if they have any photosensitized medications or conditions that they need to be aware of. So anyway, the only other downside is that there is some electric field that we can measure because it's kind of plastic and it's not grounded. So we do get a decent electric field up close to it. I don't want to put it right in front of it because I don't want to overheat my EMF meter, but we get about 500 volts per meter, so it's pretty high because it's ungrounded. We get about 700 down here. But again, it's not a big concern because you usually use it at least 12 inches away, so that EMFs, you're not really going to be exposed to much while you're using it, just a little bit when you turn it on and off. See if we can check the spectrum. We won't be able to see much because we don't have the right range. But anyway, we do see, kind of what we would expect from a classic kind of incandescent spectrum, where we get a lot of near infrared, and obviously the spectrum's kind of cut off. And you can look up Max Planck's laws. They figured out the spectrum of incandescent bulbs over 100 years ago of what to expect from an incandescent bulb. And actually, this is a halogen bulb, so it should be burning a little bit hotter, so you get proportionally more near infrared than you do with some of the cooler burning heat lamps that are only 2700 Kelvin. Usually halogens are about 3000 Kelvin. And because we have our thermopile power meter, we can try to measure the total kind of power and intensity coming from it. And we're going to try to set this up at about 12 inches away from the sensor. So we're set up. We've got a thermopile power meter, which has been traditionally used to measure broad spectrum non-coherent sources. And let's see what we get. We get 188 milliwatts because of the way the decimal place is. So it's 188, and then we have to divide that by pi to get the real intensity. So we can estimate we're getting about 59, almost 60 milliwatts per centimeter squared. And again, that's representing the whole spectrum. It's not just the near-infrared or the photobiomodulation wavelengths. It's part of that mid-infrared and some of the far-infrared that wide spectrum will cover. So it's about 60 milliwatts per centimeter squared. So that's important. We need to think about this scientifically and how to dose these things. And a lot of times companies, don't measure it or they don't disclose it for various reasons, but it's going to be important if we want to be more sophisticated. But anyway, 60 milliwatts per centimeter squared is a great amount of power, and it feels like that soothing kind of warmth and heat. If you move a little bit further away, you get less intensity and you get less heat. So make sure you adjust your distance based on how much heat you're feeling and don't overheat your skin. And finally, let's see how this kind of compares to other products on the market, because this does look like kind of a unique product, even though I think it's been around for a long time. It's just kind of flown under the radar and hasn't made its way into popularity in the USA. Maybe it's more popular in Europe, but it's kind of a curious kind of thing. So let's kind of compare it to some other products and see how it kind of fits in and what exactly is it in comparison to what people are familiar with. So obviously it's going to be a big difference compared to an LED device like our Gemba Red Vector here. LED devices are much lower power, they're lower intensity, they're using some of the relatively shorter non-thermal wavelengths. But again, it's also related to the power intensity. Our Gemba Red Vector is only 15 watts consumed, and the Beurer lamp is closer to 300 watts consumed. So, it's the intensity that drives the heat, as well as using some of the longer wavelengths. And obviously with LED devices, it's easier to use right up on the skin and target different areas and get that better penetration when you use skin contact. So, again, there's some pros and cons, but generally LED devices should be mostly non-thermal, lower intensity, just to elicit that healing response, where a heat lamp is just to warm you up and to get some of that instant kind of gratification with muscle relaxation. And obviously the closest neighbor therapeutically to the Beurer heat lamp is the standard kind of 250 watt heat lamps that are used for heating up food and heating up chickens and chickens coops, but we use it therapeutically because it's got the right spectrum. Well, like I said, the Beurer really solves a lot of problems that these have. Sometimes the heat lamps are too harsh, they've got poor beam uniformity, the light kind of spreads, and I've covered how it's got kind of hot spots and cool spots and shadows, and the Beurer seems to be well diffused. It's got this kind of pitted kind of surface to it, but the Beurer does block a lot more of the red, and these heat lamps seem to let more of the red through because it's not as dark of a coating, which is a shame because the Beurer is using a halogen technology which actually pushes the spectrum closer to near infrared, so proportionally it does emit more near infrared, but it's just cutting off more of the red. And this one's an incandescent technology. It's running a little bit cooler, and it's got wavelengths that are a little bit longer. But anyway, with the Beurer only being about $60 on like Amazon or wherever, you can get these heat lamps for about $25 in total. You could spring a little bit more money, get the Beurer, which is a nicer kind of designed for medical purposes. And this is still more of a DIY kind of thing to use a chicken coop heat lamp for therapy. And just to remind people that this technology isn't very mysterious, this is my 500 watt halogen work lamp, which we can see is very bright. It's got a huge spectrum, and it's very harsh for the eyes. So again, these heat lamps, these infrared heat lamps, there's nothing mysterious about them. They're based on basic incandescent technologies. It's not much different than these light bulbs. Again, the old style incandescent light bulbs. It's important to stay really grounded that the technology is not very mysterious, but sometimes you can build it into a nice apparatus like the Beurer has done. So anyway, that's our review of this Beurer incandescent heat lamp. It feels very nice. They solve a lot of problems that heat lamps usually have, like with beam uniformity, and they get more near infrared and they block more of the red, so it's not as harsh for the eyes. But again, it's still not great for positioning if you're trying to position specific parts of your body. But like I said, the price is right. It's about $60. That's not terrible for a heat lamp product, and you can find some good uses for it. Thanks for tuning in. Hope that helped.